G'day, I'm Pete. So, how big is the flat earth? I'm glad you asked. But if you ask a flat earther, you will either get no answer or nothing that makes sense. Let's try it out. Hey Antonio, how big is the flat earth?
I don't know. Do you?
Well, actually I do know, but it's not going to make any sense. Now, for measurement purposes, a circle or circumference is divided into 360 basic units called degrees. Each degree is then further divided into 60 smaller units called arc minutes. On the Earth, a nautical mile is a distance covered if you travel 1 arc minute along the equator or along lines of longitude. Travel 60 nautical miles and you've covered 1 degree. A nautical mile is around 1.15 miles. Okay, so how do we know a nautical mile relates to 1 arc minute? Well, in the real world, there's a couple of ways you can actually test this for yourself. In the northern hemisphere, you can observe Polaris, the North Star. Measure how many degrees above the horizon it is. Now travel north for 60 nautical miles. There you'll find Polaris is now 1 degree higher above the horizon. For every 60 nautical miles you travel, Polaris will rise another 1 degree. On the equator, during an equinox, you can place 2 vertical sticks in the ground, separated by 60 nautical miles. Now, at the same time, measure the angles. You'll find the angle is different by 1 degree. For every 60 nautical miles apart, the difference in the angles will increase by 1 degree. So it really doesn't matter what shape you think the Earth is. It's clear by these real world observations that 60 nautical miles does equal 1 degree. Now to the Gleason's map. It is the flat earther's map of choice. This map also clarifies the relationship between nautical miles and degrees. So what is the distance of the equator? Well, we know a circle is 360 degrees. We know there are 60 nautical miles per degree. So the circumference at the equator is 21,600 nautical miles. And if we know the circumference, we can work out the radius. A circle with a circumference of 21,600 nautical miles has a radius of 3,438 nautical miles. So how many degrees on a map is that? Well, we know there are 60 nautical miles per degree, so that radius is around 57 degrees. And that's the problem for flat earthers. On the Gleason's map, you have to put the real life equator at 57 degrees from the North Pole. That puts Florida on the equator. And the equator is only halfway. Another 57 degrees and the edge of the Earth is at the top of Australia. So, based on the math, the flat Earth is humongous. Using information actually on the Gleason's map, the flat Earth has a circumference of almost 68,000 nautical miles. That also means the surface area of the flat Earth is 2.5 times bigger than the globe. And what would that do to travel? I mean, in 1492, desperately short on food and supplies, Columbus sailed the ocean blue. And he only just made it. If the Earth was bigger, he'd be fucked. The president would be Jose Trump, and the most popular TV show would be Consuela's Book Club. And what about Antarctica? The shoreline would be over 4 times longer than we know it to be. Can you imagine how many laser-armed NASA spy penguins it would take to guard a 68,000 nautical mile shoreline? That'd make a lot of penguin soup. Oh, this isn't penguin soup. Not some sort of monster. It's white rhino. So, as for the Gleason's map, read the original patent. Gleason admittedly used the globe to produce a 2-dimensional drawn map of the Earth. When will flat earthers realise their map is not real? The Eiffel Tower is a real object. You can see it, you can touch it. But if you take a photo of it, the photo is just a photo of the Eiffel Tower. It's not the Eiffel Tower. You can make a drawing out of a real thing, but you can't make a real thing out of a drawing. And sadly, that's what flat earthers are trying to do. So, flat earthers, all I can say is